Hello friends, welcome back to my YouTube channel, Electrotech CC. In the previous video we had discussed about different type of mechanical switches and its application. So, in this video, we will discuss about electronics switches. So let's start. The electronic switches are also known as solid-state switches because there are no physical moving parts. There are different types of solid-state switches are available in today's market with different sizes and ratings. In this video, we will discuss some of the important solid-state switches, including transistors, SCRs, MOSFETs, triacs, and IGBTs. Before we start, you must have knowledge about different types of materials based on conductivity, types of semiconductors, and PN junction diode. If you want to learn more about it, I have already uploaded videos on those topics and links are given in the description of this video. Now, let's start with bipolar transistors. A transistor is 3 terminals and 3-layer switch, and the layers are base, collector, and emitter. A transistor basically acts as a switch and an amplifier. By combining 2 diodes like a sandwich, it works as a transistor. Based on sandwich configuration, it can be PNP or NPN transistor. Transistor is a current-controlled switch, so that when we apply small current on its base terminal, it allows the flow of current from the collector to emitter terminal. So when it allows the current to flow, or it blocks the current, it works like normal on-off switch. So transistor works in 2 different modes to work as a switch. The first mode is cutoff mode, in which the transistor work as an open switch, or we can say off switch, and the second mode is saturation mode, in which the transistor works as a closed switch, or we can say on switch. Transistor can also work as an amplifier, for that transistor work in active mode. To set the transistor in different modes, we must apply different voltage on base to emitter terminal, and that voltage is known as biasing voltage. There are 3 types of configurations, which are common base, CB, common collector, CC, and common emitter, CE. In common base, CB configuration, the base terminal of the transistor is common between input and output terminals. In common collector, CC configuration, the collector terminals are common between the input and output terminals. In common emitter, CE configuration, the emitter terminal is common between the input and the output terminals. How does transistor works? There are 2 PN junctions in transistor. 1 PN junction exists between the emitter and base region, and the second junction exists between the collector and base region. A very small amount of current flow through the base to the emitter can control a reasonably large amount of current flow through the device from the emitter to the collector. In the usual operation of BJT, the base emitter junction is forward biased and the base collector junction is reverse biased. To explain the working of the transistor, let us take an example of an NPN transistor. The same principles are used for the PNP transistor, except that the current carriers are holes and the voltages are reversed. Now let's discuss operation of NPN transistor. The emitter of the NPN transistor is made of N-type material, so most carriers are electrons. When the base emitter junction is forward biased, the electrons will flow from the N-type region towards the P-type region, and the minority carrier holes move towards the N-type region, as we already discussed in PN junction diode video. When they meet each other, they will combine, enabling a current to flow across the junction. When the junction is reverse biased, the holes and electrons move away from the junction, and now the depletion region forms between the 2 areas, and no current will flow through it. When a current flows between the base and emitter, the electrons will leave the emitter and flow into the base. Normally, the electrons will combine when they reach the depletion region, but the doping level in this region is very low, and the base is also very thin. This means that most of the electrons can travel across the region without recombining with holes. As a result, the electrons will drift towards the collector. In this way, they can flow across what is effectively a reverse-biased junction, and the current flows in the collector circuit. Now let's discuss the advantages of transistor. lower cost and smaller in size, smaller mechanical sensitivity, low operating voltage, extremely long life, no power consumption, fast switching, better efficiency circuits can be developed, used to develop a single integrated circuit. There are some limitations of transistors. Transistors have a few limitations, and they are as follows. Transistors lack higher electron mobility. Transistors can be easily damaged when electrical and thermal events arise. For example, electrostatic discharge and handling. Transistors are affected by cosmic rays. Okay friends, that's it for this video. I hope you will get useful information about transistor. If so, then like, share the video, and for more updates, please subscribe to my YouTube channel, ElectroTech CC. In the next video, we will discuss about MOSFETs. Thank you very much.